Now that you're familiar with promises, it's time to reveal an uneasy truth. JavaScript promises are kind of old. For some people, they've already been replaced by async await. But don't worry, what you already know about promises will prove to be a solid foundation for async await. If JavaScript already had promises, why did it introduce async await? Or, in other words, what's the point of having an async await in JavaScript? The purpose of async await is to make it easier to use promises in a synchronous format. In other words, don't think of async await as a new technology or paradigm. Instead, think of it as syntactic sugar for promises. Syntactic sugar is just syntax within a programming language that's designed to make things easier to read or to express. So the goal or purpose of async await is to make working with promises easier. It simplifies some of the code and makes it more clear exactly what's going on. All of this is good news. Since you've already learned a lot about asynchronous programming and promises, your understanding of async programming will carry forward to async await. So while you're going to learn more about asynchronous programming, you'll be starting with a solid base. Before getting into the examples, let's take a minute or two to define what async await actually is. To start, there's two separate keywords. The first one is async, and as you probably guessed, the second one is await. The async keyword is used to designate that a function is asynchronous. This keyword is used when functions are defined, so you can use it with either the traditional function declaration like you see on the left, or with fat arrow function declaration like you see on the right. In either case, this function will return an implicit promise, which should be somewhat comforting, because underneath the function, it's still just a promise that's being operated on. Because it's an implicit promise, it means that whatever you return will be wrapped inside of a promise. Additionally, if your function throws an error, that will be wrapped in a rejected promise. The await keyword pauses the execution of an asynchronous function while it waits for the promise to be fulfilled. There's a couple of important things to note about await. First, it can only be used inside of an async function. If you try to use it outside of an asynchronous function, you will receive an error. Second, it only blocks the current function. However, it does not block the calling functions. For example, if you had the code on the screen, the await for SomeFunc would halt getNames and not go to the doSomethingElse function. That is, until SomeFunc was done. However, it would not stop getAddresses from executing. Don't get too hung up on the details though, as the rest of the module will get into some code examples for you to see how it works. The important thing to note is that both async await and synchronous promises are both trying to accomplish the same thing. The next clip will show you how you can take an asynchronous HTTP call that you've already done in the course and turn it into a single line of code. Now that you've had a brief overview of async await, the only thing left to do is dive into some examples. Start by opening the iterating.mjs file. We're going to write code in the get function. Much like we did with consuming promises, we want to do a simple HTTP request. The code here has the await keyword before the axios.get function. This highlights that you can use await on functions that return promises. That is, you don't need a separate async await version of Axios. In fact, that doesn't even exist. Additionally, since this is now making the promise a synchronous call, you can assign the data parameter to the value of the get call. Or, more accurately, you can destructure the result of the get call into a data parameter. Before you load up the web browser, make sure you're running npm run dev so that this code will be executed. Go into the browser and choose the iterating link to load the functions for this module. When you load this page, you actually get an error in your console. It tells you there is an unexpected reserved word. If you click on the file name over on the right, it takes you to the code that you just wrote. Can you see where the error is? Well, let's go back to the code and look at that get function. Does looking at the code in your IDE help at all? Well, remember the last clip, I said that there was two important notes on the await keyword. The one that applies here is that it must be used inside of an async function. So add the async keyword to the function definition. Save that and return to the browser. This time, when you reload the page, you don't see any console errors, or at least you shouldn't. So now you can click the Get button. You once again see the familiar output in the results pane. Let's take a quick look at the code side by side. On the left, we have our promise-based approach from earlier in the course. And on the right, we have our async await-based approach. They're both accomplishing the same thing, and they're doing so in similar ways. However, with the await, it might be slightly more clear the order that the code is getting executed in. But also note that they're really not that much different. Much like with promises, what happens here when a call like this fails? The next clip will show you a familiar way to handle errors with async await. When handling errors with promises, you only had to attach a catch function. But how do you handle errors with async await? Head back to the code and copy the get function code into the get catch function. And make sure that the get catch function is async, so you don't get that same reserved word error that we got in the last clip. As we did with our promise code, change the route to get order 123, because that'll produce an error for us. In the last clip, I promised you that it's a familiar way to handle the error. Do you want to take a guess at maybe what that way is? Well, believe it or not, this is one place where it's not really related to promises. That is, there's not an await catch function. Instead, it's the tried and true try catch block. If you reload the website and click the Handle Errors button, you'll see a familiar 404 error in the response text. And you'll notice the standard 404 error in the console as well. That shows that we're handling our promise rejection. Looking at this code one last time, notice that since the error handling is the standard JavaScript try-catch block, you now have the ability to have the same error handling for both your synchronous and asynchronous code if you're using async await. Earlier we saw how promises can be chained to combat race conditions. In the next clip, I'll show you how to accomplish the same thing with async await. Async await makes sequencing asynchronous calls even easier than promises did. Start in the IDE, but this time go into the consuming.js file and take a look at the chained function to be reminded of what we did with promises. This function loaded a specific order, order number 1. After we got back our data from the API call, we made a second API call, this time to get the shipping address for our order. Finally, we used the data that was returned from the address endpoint to get the city where our package was shipped. We want to do the same thing, but this time with async await. So switch back to the iterating file, and notice that this file also has a chained function. That's where we'll be adding code for this clip. As with other functions, let's make sure that this function is async so that we can use await inside the body of the function call. Next, let's add our first API call. Now that we have our data, we want to get our address data. So let's add that API call. This time, we're destructuring data, but we're assigning it to a variable named address. Finally, we'll output the city. Heading back to the browser, we can refresh the browser and then click on the Chain button. When we do, we get the results pane updated with city::Bowling Green, which is what we'd expect. It's the same result we got with promises. Also, looking at the console, we see the orders call is the first call and the addresses call is second. This is also expected since we sequenced our API calls in that order. Let's compare our code for accomplishing this feat that we've seen throughout the course. We'll start with our original async code. We had XHR functions that called other XHR functions inside of their onload function. We upgraded this to use promises. And then we were able to put our next API call inside of a then function on a promise. And the promise code improved the XHR code because it allowed us to chain multiple then statements together to handle the flow, as compared to nesting multiple calls. And finally, compare that with the async await code. This appears to be an even better improvement than from XHR to promises. The code is a bit more straightforward. And if you wanted to chain another HTTP request, all you'd have to do is add another await statement with the next API call. The challenge is that handling async await in this fashion makes all of the calls sequential. So what if you want to make concurrent calls? I'll show you how async await can break free from the sequential calls in the next clip. We've been using async await in a way that makes sure to call asynchronous functions in a truly sequential fashion. And sometimes that's exactly what you want. But other times you don't want the functions to depend on other functions. And don't worry though, you can still use async await for that situation. Go back into your iterating file. This time make the concurrent function async. And next, let's add a call to our order statuses API. Remember, this endpoint takes 1.5 seconds. Notice that this function is not awaited. Instead, the return value, a promise, is assigned to a variable named order status. Next, let's add a second function call, this time to get the orders. Again, this function is not awaited. Next, let's set the text to be an empty string. This lets us clear the text so that we can see the data when it comes back. Keep in mind that axios.get is still a promise, and promises are eager, as we talked about at the beginning of the course. That means that the request has already been kicked off. Next, let's await our two functions. And then, after those two statements are awaited, we append our data to our response text so that we can see both results. Heading back to the browser, make sure to reload the page, and then click on the Concurrent button. After a brief pause, you'll see the data all appear at once. Before returning to the code, take a look at the console and see that the orders API call resolved first, and that the orders statuses call resolved second. By not placing an await on our Axios functions, we allowed both API calls to kick off at one time. Returning to the code, take a look at the await statements. We're awaiting the order status first, which means we won't do anything with our orders data until after we get the data for our order statuses data. But because order statuses is slower, by the time the await is complete, the request for orders is already complete. So both calls were running at the same time, even if we did tell the code to wait on the slower request first. There's one more possibility for these calls. What if we wanted to handle the same two calls but show the data in the order that it comes back? In the next clip, you'll see how to handle that exact case. Part of the power of asynchronous programming is that you can make parallel calls so that you're not blocking a fast-running process with a slow-running process. You can do that exact thing with async await. Start, as we've done every time in this module, by making the parallel function async so that we can use await inside of it. Next, let's set the text to be an empty string like we just did with our concurrent calls. Before we add more code, remember that async await is syntactic sugar on top of promises. So we have the ability to mix and match them. Let's start by awaiting a promise.all. This will wait until all of the promises that we pass in are complete before continuing. Also remember that async functions return an implicit promise. So let's add our first promise. Let's pause here for a moment because this might be unfamiliar syntax. We're starting by creating an anonymous async function. This function will return a promise, and that will be our first promise. The body of our anonymous function is the familiar async await call to get our order statuses. Next, let's add a second promise, and this time it'll be for our orders call. With this construct, we now have two promises in the array of promise.all. And as we saw in the previous module, promise.all will kick off each of the functions and wait until they're all complete before returning. And since we're awaiting the promise.all, the parallel function won't end until all of our promises are done. Head over to the browser and reload the page. Now click the Parallel button on the screen. Almost instantly, you'll see the first order on the screen. Then, after about 1.5 seconds, the order status will appear. If you check out the console, you'll see that once again, orders finished before order statuses. But with this approach, the code was handled as the individual promises settled. So you have an example of how you can combine promise functions with async await, and that'll actually cause parallel execution to happen. With that, you're ready to go out and tackle asynchronous programming in JavaScript. One of the first and most important things that you learned in this course was that every promise has one of three states: pending, when the promise has not yet settled; fulfilled, when the promise returns successfully; and rejected, when the promise has an error or is unsuccessful. We used these three states to kick off requests, handle the return data, or display the errors that came back from the API. You also learned how to create your own promises, and this will be helpful as you begin to create your own asynchronous code or wrap existing functions and turn them into promises. Remember, to create your own promise, you only need to create a new promise object and then pass in the executor function with a resolve and reject parameter. You can then decide when to use each of those two parameters to update the state of your promise. Then you learned about async await. And my hope for you is that while you learned some new key words, the concepts were already familiar. At the end of the day, async await excels at the ability of turning asynchronous code into sequentially executed code. You can make them be concurrent or even parallel. But one of the best places to use them is when you need your code executed in a particular order. Finally, thank you for taking the time to watch this course. I really enjoyed working through promises and async await. I know they can be tricky topics. Hopefully, though, we've been able to demystify the asynchronous concepts. I'd love it if you'd leave a rating for my course, and I'd also love to hear from you. You can reach out to me on Twitter at the address on the screen.